Okay, so let's continue on in section 3.2. The second part involves graphing log functions. Okay, so when I started section 3.2 with you, right, I showed you how to graph using the inverse, right, b to the x, and I would switch some coordinates, horizontal asymptote becomes vertical asymptote. But this time I'm going to graph log base b of x directly with you, okay? So with any function, right, you start by plugging in some points, and even though there's no numbers over here, you want to think about what can I plug in into this function, right, into my x, such that I don't need a calculator to evaluate. And if you remember some, good log properties that we've learned, if you plug in 1, right, f of 1 would be a nice point to plug in because we can evaluate log base b of 1, right? Log base b of 1, this is saying b raised to what power gives you 1, right? B raised to what power gives you 1. And clearly the question mark in this case, right, would just be 0. So over here, you're going to get 0. Another easy point to plug in to evaluate would be b, right? If you plug in log base b of b, well, this is just your inverse property, right? The exponent in this case is the answer, right? If you plug in b, you're going to get 1. Okay, so you do remember a few restrictions for your base, right? Your base has to be a number that's greater than 0, and b cannot equal 1, right? And so before we graph this right here, we have 2 points. The other thing you need to realize for log functions, right, is that they have a vertical asymptote. Okay, so the vertical asymptote in this case is I set the argument, this is called the argument, equal to 0. Okay, I set the argument equal to 0, and I solve for x. In this case, the vertical asymptote is just x is equal to 0. All right, so if we were to sketch it, maybe this will be 1, this will be 1, this will be 1, this will be 1. Maybe draw 3 tick marks. Okay, so over here, if I plug in my 2 points, 1, 0 is the x-intercept. Now b is a number that's greater than 0. It can't equal 1, right? So b technically is greater than 1. B, 1 would be somewhere over here. So this is b, 1. And we have a vertical asymptote. And so your graph of your log function is going to roughly look something like this. Okay, it's going to approach the vertical but never ever cross. All right, so that's the parent function of a log function, right? Of course, if you were to graph the inverse, right, the inverse is just b to the x. It would be reflection of the line over the line y is equal to x. Okay, so there's f of x and the vertical asymptote. Again, you set the argument equal to 0 and you solve for x. All right, so what's important about the characteristics of a log function other than the fact that it has a vertical asymptote? The domain, of course, is just, minus infinity to infinity. The domain is not minus infinity to infinity. The domain is found by setting the argument greater than 0. And so if I set my argument greater than 0 and solve for x, x again has to be a positive number, right? You can see from the graph that x is always going to be positive in this case. And the range, right, is minus infinity to infinity. Okay, so for interval notation, right, of course you can write 0 to infinity. It doesn't really matter which notation you use unless I specify. You also have an x-intercept on this graph. The x-intercept in this case is 1, 0. And that's going to be important because in the homework they're going to ask you to find the x-intercept. All right, now, what is the general form of a log function? The general form of a log function, of any log function, is going to be in this format. We'll call it f of x is equal to a log base b of x minus h plus k. All right, so this form looks very, very familiar, right? A changes the size of the graph vertically. So if the absolute value of a is greater than 1, vertical stretch. If the absolute value of a is between 0 and 1, vertical compression, or you can call it vertical shrink. Again, b is your base. H shifts the graph left and right, K shifts the graph up and down. Technically, I could put a horizontal shrink or stretch factor here, but let's not overcomplicate things, okay? So again, quick review, the way you find the vertical asymptote is you set the argument, right? The argument equal to 0, and you solve for x. In this case, x is equal to h. And the way you find the domain is you set the argument greater than 0, and you solve for x, okay? So x is greater than h. So again, really important that you understand this concept that the domain of a log function, right? Whatever's inside the argument has to be greater than 0, because if you convert this to exponential form, right? If I say, hey, b to the y is equal to x, right? Remember, b is a positive number. You can't exponentiate this b such that you get x as a negative number, right? X can't be negative, right? Doesn't matter how you, exponentiate your power of y, right? This side right here, you can't raise this to any exponent such that x is a positive number. That's why the domain for a log function in this form, right? You always solve by setting the argument greater than or equal to 0, and then you solve.